the next topic we're going to be working on is the difference quotient. Now, the difference quotient is a fraction, that's what quotient means, and it's used to understand the rate at which functions change, which is covered heavily in future courses. Now, for this college algebra course, we will need to understand how to evaluate this ratio. We don't really need to understand what it means, we just need to be able to do the algebra part and the mechanics of it so that when you get to the next class, it makes a little bit more sense. So here is the definition, which you do not have to memorize until you get to future classes. In this class, I'm just going to go ahead and give it to you, where we have the function f of x plus h, so that's this part right here. Then we're going to subtract f of x and then divide that whole thing by h. And it says where h is not equal to 0, h can't be 0 because we're not allowed to divide by 0. So for our first example, we have f of x equals 6x plus 1. Now I'm going to do f of x plus h. The part in red that I underlined in red here is the part that actually takes a lot more work than the other parts. So I'm going to come over here onto the side and just evaluate f of x plus h. So for my function is 6x plus 1, but I'm going to take out the x and replace the x with whatever's in the parentheses, in this case x plus h. Now when I distribute this, I'm getting 6x plus 6h plus 1. So that actually wasn't all that difficult, but some of the future ones are going to be a little bit harder. So let's go back to the definition of the difference quotient. So in red, I'm going to put my 6x plus 6h plus 1. Then the rest of the fraction says minus f of x. So minus, so I'm going to subtract f of x. Now the f of x that I'm subtracting is given to me. F of x is 6x plus 1. Notice that I put this in parentheses. You have to put this in parentheses because of the minus sign. Because there's a minus sign in front, the minus needs to be distributed to both of the terms. So if you don't put it in parentheses, you'll probably only attach the negative to the first term, and then you're going to mess your whole problem up. So, and then all of that's over h. So we have 6x plus 6h plus 1 in red. In blue, I'm going to distribute my negative, so that's going to be minus 6x minus 1. Again, this is all over h. Okay, so that's quite long, and the next couple problems are going to get even longer here. Alright, so now I want to combine like terms. Well, I have 6x minus 6x, and that adds to 0. I also have 1 minus 1, and that also adds to 0. In fact, the rule of thumb here is that all of your blue terms are going to add to 0. All of the terms that you have left in the numerator should be red terms, and they should all include an h. In this case, there's only one term, which is awesome, and it truly does include an h. So I have 6h over h, and now you can see that the h's can divide out because there's an h on the top and an h on the bottom in every term. So when I finish my problem, I'm just left with 6. So that's just a constant number. But some of your other problems are going to have letters in them with x's or h's. In this case, all the x's and h's either added to 0 or divided out to 1, so they went away, but you might have x's and h's in future problems. Alright, let's do this again. For the next problem, again, I'm going to come over on the side of my paper and do f of x plus h, again, because that takes a little bit of effort here. Notice I have a quadratic problem instead of linear, so it's a little bit trickier. So we have x plus h squared minus 3 times x plus h plus 9. So that's x plus h times itself. Whenever you have a binomial times itself, you really need to write it out twice because it means multiply it by itself. Then when you distribute, you won't forget that middle term. Sometimes people try to take the 2 and distribute it to both, and you're going to make a mistake there. So write it out twice, and then FOIL or double distribute. X times x is x squared. X times h is xh. H times x is hx, but I'm going to reorder it just so it's in the same order here. xh plus h squared. It doesn't really matter how you order it, just try to make them the same so that you can see that they are like terms. Minus 3x minus 3h plus 9. And then there's one more thing to do. XH plus XH are like terms. So when I add them together, don't forget you have an invisible 1 in front. So 1XH plus another XH gets me 2XH. Sometimes students will accidentally make that squared or something. They'll be messing with the exponents, but you can't do that when you're adding. Okay, that was a lot of work, and that only got me the red part of my difference quotient. So I'm going to go ahead and look at the definition that says f of x plus h goes first, so that's in red here. Minus, because there's a minus in the problem, f of x. So the f of x is x squared minus 3x plus 9. Notice that I put it in parentheses. Now that when I distribute those, I am going to be changing all of the signs of the blue terms. All of the red terms stay the same, and I know you're like, oh, that's a lot of writing, but do it anyway. Minus x squared plus 3x, because a negative times a negative is a positive 3x. A negative times a positive is a negative 9. And at this point, this is as long as nasty as it's going to get, because at this point, things are going to start adding to 0. So x squared minus x squared, that adds to 0. 3x minus 3x, that adds to 0. Positive 9 minus 9, that adds to 0. And all of the blue terms should go away. The only thing left I have is red terms, and all of the red terms that I have left should have an h in them. And they do. Each one of those has an h in them. In order to divide those out, I'm going to factor an h out of the numerator. So every term I'm going to take an h out. Now that I've factored that, the h and the h can divide out, and my answer is 2x plus h minus 3. Notice our first problem ended in a constant, and this problem didn't end in a constant. It had x's and h's and constant. It had lots of things. So that was fun. Let's do that again one more time. Again, I'm going to start with the red, f of x plus h, and I'm going to work that out. We have negative 2 times x plus h squared plus x plus h plus 5. So when I'm trying to evaluate this, I'm going to take the negative 2 times x plus h times itself, x plus h. Anytime you have a binomial squared, you need to write it out twice. Now, this is tricky. I have 3 things being multiplied here. Now, a lot of times people will try to multiply all 3 of them at the same time, and you just can't. If I ever ask you to multiply 3 numbers together, what you do is you take 2 numbers, multiply them, take that answer and multiply it by the third number. And that's exactly what we're going to do here. You can't multiply 3 things at the same time. So I'm going to pick to multiply the x plus h times the x plus h. Then after I'm done there, then I'm going to go back and multiply the 2 times the result. Okay, so x times x is x squared, x times h is xh, x times h is xh. Again, I'm going to put it in the same order. Doesn't really matter which order you pick it in, just put it in the same as the first one you chose. Now that I've distributed x plus h squared, now I can go back and multiply the negative 2 to every term. Negative 2x squared minus 2xh minus 2xh minus 2h squared plus x plus h plus 5. Whew, that's a lot. One last thing I can do over here before I need to go back to my definition is to add negative 2xh minus 2xh. Minus 2 minus 2, that's really minus 4xh. All right, that was a lot of work. So now I'm going to go back to my difference quotient. And I have f of x plus h. That's all of those terms in red. That's a lot of terms, so go ahead and write them in. Take as much time as you need so that you're not missing a negative. Okay, then my difference quotient says minus f of x. Well, my f of x in this case is negative 2x squared plus x plus 5. Now I distribute. So you get negative 2x squared minus 4xh minus 2h squared plus x plus h plus 5. Okay, so when I distribute the negative, a negative times a negative is a plus 2x squared. A negative times a positive is a minus x, and a negative times a positive is a negative 5. Okay, that's a lot of terms. Now we're going to start adding the terms to 0. Any terms that are exactly like negative 2x squared and positive 2x squared, add to 0. Negative x, positive 5, negative 5. And all of the blue terms should add to 0. They should be gone. And all you have left should be red terms that have h's in them. So negative 4xh, yep, that has an h. Minus 2h squared, yep, that has an h. Plus h all over the h. At this point, in order to get rid of the h or divide the h out, I first have to factor the h out of all of the terms in the numerator. So I see an h in all of them, so I can divide an h out. And then the last thing is the h and the h can divide nicely. And I am just left with negative 4x minus 2h plus 1. And that concludes this lesson.